Hello, dear students. We are going to learn about tension. Okay, uh, tension is a type of force. Okay, we are going to learn acceleration, how to calculate acceleration and tension when different bodies are connected by strings. Okay, for you guys, this is a little strange topic. Okay, but if you look at multiple choice questions of laws of motion chapter, most of the problems they involve these strings and normal force, etc. Okay, I'll give you just one small introduction within 1 minute, then I'll get into the topic. Okay, see, two different words that you have to learn. Okay, two different concept, that new concept that you have to learn here is, one is called normal force. Okay, normal force. What is a normal force? Say there is a mass, okay, which is placed on ground. Now what is the force acting on the mass? Force acting on the mass here is mg, and that is always downwards towards the center of the earth. uh, if force is acting on the mass, that mass should go down, no? Correct, no? But it is not going. Why it is not going? Okay, say there is some reaction force developed between two surfaces. Okay, now what is that reaction force is acting upwards, resultant reaction force is acting upwards, or we call it as normal reaction. Okay, normal reaction. What is normal reaction? Reaction force perpendicular to the surface of contact. Okay, now this normal reaction which is acting upwards, okay, is equal and opposite to mg. So therefore what is the net force? N minus mg, net force N minus mg is equal to 0. Since the net force is 0, this body continues to be at rest. Newton's first law, remember. Okay, if the body has to move, there should be an unbalanced force. Here there is a balanced force. That is why this body continues to be in the state of rest. Okay, this is one thing. Yeah. Normal reaction or reaction force. Okay, then another force that you have to learn is, say for example, there is a fixed ceiling. Now one mass is being hung from the ceiling, okay, using a string. So this is a string. Okay, in laws of motion chapter, unless specified, this string is, okay, this string is massless. You have to assume that this string is massless, and you cannot, and it is inextensible. This string is massless and it is inextensible. Like for example, in straight line chapter we neglected air resistance. Correct na? Now you see this mass is hung using this string. Okay, on this mass there is a force mg acting which is downwards. It is natural, gravitational force is acting, but this mass is not falling down. Why it is not falling down? There is some force here in this upward. There is some force upward. Definitely that force is being developed in the string only, because other than string there is nothing there. If there is no string, the mass would fall down. That force we call it as force of tension. Okay, so there is a tension for the string. What is the tension of the string? Mass. More the mass, more string, more tension. Correct na? So for example, tomorrow there is a physics test. There is some tension. Physics also is there, chemistry is also there, maths is also there. Then tension is more. More the mass, or if you connect more masses here, more tension in the string. That is the literal meaning. Same meaning we are using. Tension with respect to string. That's why we call it tension in the string. So the nature of force of tension is electrostatic. Means when you pull a body, okay. So basically, why you cannot break the string is because of the intermolecular forces. Okay. I'll explain that in future. Okay. Now try to remember some force is developed in the string. That force is called tension. When you pull the string along its length, okay. See, when you take a string, if you apply force on the string in this direction, then there will not be a tension. The string will become like this. Correct na? So you have to apply force on the string along the length of the string. So here mass mg is applying force on the string along the length of the string. That is why a force of tension gets developed. Correct? Na? So you have to remember these two words. One is reaction force, one is tension. Okay, keep it in mind. Now we'll come back to the core topic, acceleration and tension. Okay, in the next 4 or 5 videos are very very important, and trust me, you will remember me. Okay, when in your class acceleration, tension and loss of motion chapter is start. Okay, concentrate. First case, what I have taken a ceiling. There is a mass m is being hung from the ceiling. Okay, now to solve problems in mechanics, we have to use something called free body diagram. We have to use something called free body diagram. Free body diagram. What is this free body diagram? We'll see. Okay, I'll be using FBD. FBD stands for free body diagram. Okay, yeah. What does it mean? There are many steps. Okay, we don't have to learn all the steps. Okay, what it is we'll learn. Okay, free body diagram. Okay, first make this body free from this scenario. Okay, you write it here. I am writing free body diagram of M. Make it free, that's it. Remove all the other parts and write only that M. Then on that mass M, which are all the forces acting, draw them. Okay, specify them. One force acting on M is mg. Another force acting on M is T. So this is the free body diagram. Very simple. Okay. Now this mass is at rest. Correct? Na? This mass is at rest. So therefore, or rest means this mass is in equilibrium. What is equilibrium? If the net force acting on the body is equal to 0, then the body is said to be in equilibrium. If the net force acting on the body is equal to 0, then the body is said to be in equilibrium. Okay, it is at rest, it is in equilibrium. If the body is at rest, it is in equilibrium. Because if the body is at rest, net force acting on the body is 0. Okay, then upward force equal to downward force. T is equal to mg. So this is how you write the equation for tension using free body diagram. Okay. Now for this particular problem, it may appear very simple to you. Okay, we'll go forward. Okay. Yeah, this is how you write free body diagram. Suppose say mass is given. Say m is 60 kg. What is the tension? What is the tension? Tension is equal to mg. Okay, 60 into g. What is g? G is 10. So tension equal to 600 Newton. This is how you are solving the problem. Next, what we'll do? Let me consider two masses. Let me consider two masses, M1 and M2, connected by strings. Now, this string is different, this string is different, correct? Na? These two are different strings and they should have different values for tensions. Because what is the tension for this string? Only this mass is the tension. It has to hold only M2. What is the tension for this string? This string has to withstand the force of M1 and M2. So tension here is more, tension here is less. Okay, we will see, we will calculate. Say the tension here is T1. Say the tension here is T2. Okay, I have written two directions for tension. Why I have written two directions for tension is, okay, you have to observe. With respect to ceiling, okay, string is trying to pull the ceiling down, correct? Na? If the ceiling is not strong, then the ceiling will come down, na? Correct? Na? If the ceiling is not strong, say you have hung a very huge mass, then the ceiling will fall down, na? Correct? Na? So means what is that? String is trying to pull the ceiling. At the same way, at the same time, string is trying to pull the mass up. String is not allowing the mass to fall down. Correct? Na? So with respect to the mass, what string is doing to the mass? It is trying to pull the mass up. What string is doing to the ceiling? It is trying to pull the ceiling down. Correct? Na? With respect to the mass, tension, direction of tension is up. with respect to the ceiling, direction of tension is downwards. Or you can remember, tension is always away from the body towards the support. With respect to mass, tension is always away from the body towards the support. Okay. When we solve 2 or 3 problems, you'll come to understand clearly. Now I'll write free body diagram of M1. Free body diagram of M1. Okay, I'll write M1 here. Which are all the forces acting on M1? One force acting on M1 is T1, which is acting upwards. T2 is acting downwards. Remember what this string is doing. This string is trying to pull M1 down. Correct na? That is why direction of T2 is downwards. Then one more force acting on M1 is M1G. Correct na? You should not forget gravitational force M1G. Now this is at rest. Correct na? This system is at rest. Correct na? That since there is a fixed ceiling, so therefore the system is in equilibrium. Upward force is equal to downward force. So T1 is equal to T2 plus M1G. T1 is equal to T2 plus M1G. This is one equation. Then I'll write free body diagram for M2. I'll write free body diagram of M2. Free body diagram of M2. I'm writing M2 here. Which are all the forces acting on M2? T1 is acting up. T2 is acting up. Correct now on M2. T2 is acting. Okay, this is very, very important. See, with respect to M1, T2 was downwards. With respect to M2, T2 is up. Means, okay, for this mass, this string is pulling this mass up, but the same string was pulling this mass down. Remember, very important. Okay, and one more force, M2G. You should not forget gravity. Yeah, M2G is acting downwards. Now what happened? So since the mass is at rest, upward force equal to downward force, it is in equilibrium. T2 is equal to M2G. We got an equation for T2, but here T2 is there now. What happens to this equation? T1 is equal to M2G plus M1G, or T1 is equal to M1 plus M2 into G. I told you T1 is bigger. Correct now? T1 has to withstand both M1 and M2. Yeah, T2 has to withstand the weight of only M2. So T2 is less, T1 is more, and we got it. Correct now? T2 is equal to M2G. T1 is equal to M1 plus M2 into G. Now we will see how to generalize this situation. Say, let us suppose that there are many masses connected. Okay, say here there is a mass M1, there is one more mass M2, there is one more mass M3, there is one more mass M4, there is one more mass M5. Okay, these are connected. M5, M4, M3, M2, M1. Okay. Tension here, let it be T1. Tension here, let it be T2. Tension here is T3. This is T4. This is T5. Let us write the equations. Okay. If you look here, T2 is M2G. T1 is M1 plus M2 into G. So here what we can write? T5 is equal to M5G. Then what is T4? T4 equal to M4 plus M5 into G. M4 plus M5 into G. Similarly, I can write T3 equal to M3 plus M4 plus M5 into G. M3 plus M4 plus M5 into G. T2 I can write M2 plus M3 plus M4 plus M5 into G. What is T1? T1 has to withstand the weights of all the masses. M1 plus M2 plus M3 plus M4 plus M5 into G. So what we have done, we have written the equations without using free body diagram, because now we are becoming experts, right? Yeah. Next, this is the situation. Say there are two blocks. Okay, these two blocks, there are two blocks. Say this is M1 and this is M2, and these are connected by a string. Okay. Now you have applied some force here in the horizontal direction. Therefore, the system accelerates with some acceleration A. Let us suppose that in the calculations that we are doing, there is no friction. The surface that we have considered is frictionless. Unless they specify, you don't consider friction. Okay, you don't consider mass of the string. Okay, you consider it is inextensible. Okay. So it is a frictionless surface. Okay, so there are two masses M1 and M2 connected by a string, and you have applied a force F along the horizontal, and because of that there is some acceleration A. Yeah. Now I'll write free body diagram of M1 FBD of M1. I'll write here. I'll write free body diagram of M2. Okay, M2. Yeah, what happens on M1? Which are all the forces acting? M1G is acting downwards. Normal reaction is acting upwards. But the blocks are moving along the horizontal, no? So upward, these vertical forces are not required for us. They get cancelled. You don't have to write them. Okay. Then here force of tension is acting here. Correct? Na? Here there is a force of tension in the string. Due to that force, M1 is being accelerated. So what is the equation for this? F is equal to M into A. F is equal to M into A. Yeah, F is equal to M into A. So this is one equation. T is equal to M1A. We got it. Now what is A? We will find out. Okay, that can be found using by writing free body diagram for another mass. What about free body diagram of M2? We will see. M2. So force is F is acting in this direction. T is acting in the opposite direction. See, this is very important. Okay. Yeah. Because this string is pulling this M1 in the horizontal direction. Correct, na? But when the force is applied on M2, this string is resisting its motion. Correct, na? It is trying to pull in the opposite direction. Yeah. So these two forces together are responsible for acceleration. Okay, M2 is accelerating towards your right. Correct, na? So therefore, which force is bigger? F is bigger. Correct, na? That is why acceleration is in the direction of F. So therefore, I can write an equation F minus T is equal to M2A. F minus T is equal to M2A. Yeah. Now I know the value of T, na? I can substitute here. What is this equation again? It is F is equal to ma. What is this? Net force is responsible for acceleration of mass M2. That is how you should read it. So F is equal to M2A plus T. Correct, na? Plus T. What is this T? M1A. M1A. So what happened? F is equal to M1 plus M2 into A. We knew it. F is equal to ma. And what is acceleration? Acceleration is equal to net force divided by total masses, M1 plus M2. Okay, we got acceleration. Then now, therefore, what is tension in the string? Tension is equal to M1 into A. What is A? M1F divided by M1 plus M2. So this is how you calculate the equations of acceleration and tension when the masses are connected by strings by using something called free body diagrams. Now we will generalize this situation. Shall we? We'll generalize this equation. There are many masses. There is M1 here. There is M2 here. There is M3 here. There is M4 here. And these are connected by strings. Since these are different strings, say tension here is T1, tension here is T2, tension here is T3, the force applied is F, and the whole system is being accelerated with an acceleration A. Now, coming back to the previous situation, T equal to M1A, correct na? T equal to M1A. How to write equation for A? total force divided by total mass. Correct na? What we'll do? T1 equal to, directly I can write T1 equal to M1A over. Okay. Then here see, T1 equal to M1A, F equal to M1 plus M2 into A. See? So what I can do? T1 equal to M1A, therefore T2 is equal to M1 plus M2 into A. M1 plus M2 into A. T3 is therefore equal to T1, T2, T3. T3 is equal to M1 plus M2 plus M3 into A. F equal to M1 plus M2 plus M3 plus M4 into A. Correct na? And what is the equation for A? Acceleration equal to, therefore, F divided by M1 plus M2 plus M3 plus M4. So therefore equation for tension, you can substitute the equation for acceleration everywhere. Correct now? So this is how you write the equations for tension and acceleration when the bodies are connected by a string. Say we will try to solve one simple problem. Okay. Say there are two masses. Okay. There is a mass of 10 kg and there is one more mass 20 kg, and they are connected by a string. Some force say 100 Newton is being applied on the system. Okay, now what we have to do? The question is this. The question is calculate acceleration and tension. Calculate acceleration and tension. What do we do? Directly we know the equation for tension here. Correct na? Tension is equal to M1A, if you remember. Correct na? Tension equal to M1A. What is or what you can do? You have to write the free body diagram and you get the same equation. And we have done it. Correct na? Same situation. We have done it. Same situation. What is tension? Tension equal to M1A. Okay, we got it. So we can directly write. So what is acceleration? Acceleration equal to net force divided by total mass, M1 plus M2. Correct na? So what is tension? Force of tension is equal to M1 10 kg into acceleration. We don't know acceleration. First we'll find the acceleration. What is acceleration? Acceleration equal to force 100 Newton divided by M1 plus M2. Okay. 10 plus 20, it is 30. 3 goes. It is 3.33 meter per second square. Okay, 3.33 meter per second square. So tension is equal to 10 into 3.33 meter per second square. So tension is equal to 33.3 Newton. So hope you understood this. Tension is equal to M1A. Okay, M1 is 10 into A. So we were not knowing acceleration. So we calculated acceleration. Acceleration equal to F divided by M1 plus M2. F is 100. M1 plus M2 is 10 kg plus 20 kg is 30 kg. 0 cancel. 10 by 3 is 3.33 meter per second square. 10 into 3.33 will give you 33.3 Newton. This is how we solve problems. Okay. Please be careful as far as next 3-4 videos are concerned, because we are going to learn about inclined planes, we are going to learn about pulleys. Okay, these are some of the concepts that you feel difficult in your PU days. Please ask with your seniors, those who have completed their second PU or those who are doing first PU or second PU. Ask them how about problem solving in loss of motion chapter. Okay, how about pulley problems, tension problems and all. Get some inputs and put your head. Okay, give your time. Okay, so, make a notes, start solving problems. Okay, hope you understood all the topics today. Thank you very much.